The only person in this conference.
So, is it audible? Is it audible? Yes? Okay, great. So, let us start. So, equilibrium of forces in 3D. So, in this, right? So, we learned the necessary and sufficient conditions for the system of forces to be under equilibrium condition. Now, we have discussed something related to wrench. So, wrench is nothing but the situation where the G axis, which is nothing but the moments axis, and the resultant force axis, if one is parallel to the other, then actually we say that particular scenario as wrench, right? So that is, so there are a definition for that one. So just note down the definition, then actually we can prove that. A combination of a single force R and a couple G is said to constitute a wrench if the line of action of the of the single force R on the axis of the couple R and the axis of the couple G are same. That is, if the vectors R and G are parallel, right? So this is what is called a wrench. That means couple and the resultant force so has to be parallel to each other. So that's what is the scenario. And then there is one associated theorem. So that theorem, what it says is, any system of forces acting on a rigid body can be reduced to a single force together with a couple with a couple whose axis is along the direction of the single force. Is along the direction of the single force. The direction of the single force. So the same statement can be rewritten as every system of forces acting on a rigid body is generally equivalent to a wrench. Is generally equivalent to a wrench. So this is the associated theorem. Got it? You note down this. We are going to prove this. Done? Okay. So let us say there are n number of forces that are acting on a rigid body. So on this rigid body there are many forces that are acting. Now as per the theorems what we have discussed, right? So all the system of forces generally results into a single force along with a associated couple. The extension of that associated couple is there will be at least one situation such that the axis is parallel to the resultant force, right? So now actually that extension what we are going to learn it now. See this. So all the forces together can be represented into a single resultant force. Let us say this is the force which is the single resultant force which is acting on the body. So this is the equivalent of all the forces together. Now let us say, so draw a perpendicular line like this and draw a perpendicular line like this. That means these are the coordinate axes for us. So if this is x-axis and this is y-axis and this is z-axis. Now on this situation, so this is the base part. Now actually, so if there is a G that is acting in this particular direction, this is the G which is the resultant couple. So this G is the resultant couple and this is the resultant force. So this is the resultant force and this is the resultant couple. Now definitely there will be an angle in between these two. So there is an angle associated between this G and R. So G is the resultant movement and R is the resultant force. So the axes of both are different. Let us say the angle between them is theta. Then this theta can be divided into two different components. So this is one component and this is another component. So this component of momentum is G sin theta and this component of the moment is G cos theta. Got it? So this is G cos theta and this is G sin theta. So which essentially means that this particular moment, whatever it is there, right? So I have divided into two different components here. And this component which is perpendicular to the plane of yz. So G sin theta is perpendicular to the plane of yz. So this is perpendicular. That means the system of forces which results into this particular component of the moment is acting on this particular plane. Hence, this is perpendicular to this particular plane of yz. And similarly, g cos theta can be treated as a perpendicular component of the resultant of all the forces which are acting on the xz plane, right? So this is g cos theta and this is g sin theta. Now here, let us say this g sin theta is a resultant of the movement of the forces which are acting on the yz plane, right? So for that, what I will do is, I will just draw an equivalent force of minus r here and plus r here. So see this, these two are perpendicular to each other. I have drawn in a slant manner. Ideally, this is how it is. My finger is, which is perpendicular to the board. So this is the axis of z. So that means, so if this is one force and there is one force exactly on the board downward, and there will be one more force actually I can draw at a location like this, whose movement of the force, that is, one force is this one and another force is this one, and let us say I am calling this as R. So I have drawn two different opposite forces whose resultant movement is this one, which is nothing but g sin theta. So being these two are on the same plane of yz, so I can flexibly draw that one force downwards and one force upward, and whose moment is equal to g sin theta. And I am considering that this one of the force is equal to R. So if this is equal to R, then I can decide this value so that it can match this g sin theta, which is the couple of these two forces, R and minus R. So I call, let us say this is O dash, then this is nothing but a perpendicular distance between the forces R and minus R, right? So O dash multiplied by this R is equal to g sin theta. So is this statement true? Is this statement true? I hope it is understood. See this. This is nothing but I am drawing this line like this. So this is z axis. Now this is the origin O, and here actually there is one resultant force that is acting R. Now actually I have drawn two different resultant forces. This is R and this is also R. So this is R and this is R actually I have added, and this is a randomly chosen point where the randomly chosen point should be such that the perpendicular distance between these two forces, which is nothing but the couple. So this is nothing but couple. And this couple, the moment is nothing but the force multiplied by the perpendicular distance. So this is the perpendicular distance and multiplied by the force. Then this should be equal to the moment, because there is a moment whose axis is perpendicular to this plane of yz. So this is the plane of yz. I have drawn an axis like this, and the moment value is g sin theta, which is a resolved component of this g. Got it? Understood or not? So this way actually I can justify that the perpendicular distance multiplied by r is equal to g sin theta, which essentially means that this O dash value should be equal to g sin theta by r. So if I select the O dash point such that it is equal to g sin theta by r, and definitely actually this statement has to be true. Got it? Understood or not? So if I draw this particular situation, I can say that this r and minus r will cancel out. If r and minus r will cancel out, then I am left with only one force which is acting at O dash, and that force magnitude is r. Got it? See this, these two are actually randomly chosen forces, and these randomly chosen forces actually I have selected such that it is equivalent to r, so that I can calculate the O dash value simply. Got it? So this is a randomly selected moment whose magnitude should be equal to g sin theta. Got it? And that random value I have kept as r. Hence O dash should be equal to g sin theta by r. So this is for the simplicity purpose. Now if these two forces are cancelling out, then I left with only one R value along with a component of the couple which is acting parallel to this R. That means I am left with two things now. So one is G cos theta and another is, so actually perpendicular line like this, and here this value equal to R. So these two are actually left over now. So the resultant of this actually finally came to a situation of cancelling these two forces and left with only one force R along with the previous one component of the moment which is acting on this axis of Y, which is equal to G cos theta. Now if you notice in this particular scenario, R and G cos theta are always parallel to each other, right? Yes or no? R and G cos theta are always parallel to each other, which essentially means that G cos theta and R always forms a range, right? So, which means that R and G cos theta always forms a range. Because these two are parallel to each other, and this distance is in between these two is, this is O and this is O dash. Got it? So this is the axis of rotation. This is the axis of the resultant force. Now the axis of the rotation and the axis of the resultant force, if both are parallel to each other, then that scenario we are calling as the range. Why? Why we have to call that as a range? Any correlation between a normal mechanical wrench versus this particular scenario? Can somebody give me? This particular scenario can be correlated to a normal mechanical wrench. See this. Let us say this is one particular bolt, and let us say there is a nut on top of it. Then to tighten this nut, right? So the wrench has to be put in like this, and it has to be rotated like this. If it has to be rotated like this, then actually the axis of this rotation is going to be perpendicular to this base, which is nothing but the chalk piece direction like this. So this is the axis of the rotation. So, but the nut is moving in a circular fashion like this. And then if you notice, if the nut is rotating like this, then actually this axis is top direction. At the same time, the nut actually is going to push this chalk piece upwards like this by tightening that nut. Got it? So the resultant force direction is upwards. At the same time, the torque direction, which is happening in the circular manner like this, and whose axis is again the direction of the force. So these two together, it constitutes a wrench. Got it or not? The axis of rotation is this one, and the resultant force is also this one. Got it? What happens to the G sin theta? See this. This G sin theta is replaced with two different forces, this R and this minus R. So G sin theta actually, so we have removed this G sin theta and we have placed these two forces. And these two forces are again resulting in cancellation of these opposite forces and left with only one force along with the G cos theta. Got it, Arun? Got it? So these two are introduced in place of G sin theta. So you can note down this. Any questions you can let me know. Any questions? Done. So now actually from here actually we can make out. So there are certain names actually that were given to this R. So that is, this R direction is nothing but which is the resultant force for S. So that resultant force is called as the central axis, right? So the resultant force line of action which is at O dash and parallel to G cos theta is called as Poinsot's central axis. Poinsot central axis. For a given system of forces, the central axis is always unique. For a given system of forces, the central axis is always unique. So this is one important property, and there is one more important property, that is the moment G cos theta, which is always, if you take the base point on the central axis, G cos theta will be always lesser than if you take the point of base other than the central axis. So as a statement wise, you can write this as the moment of the resultant couple. The moment of the resultant couple with a point on the central axis base point on the central axis is less than the moment of the resultant couple is less than the moment of the resultant couple corresponding to any arbitrary point O which is not on the central axis. That means if you take the base point on the central axis, so the moment will be less, because if you notice, the moment along the central axis is G cos theta, and G cos theta value is always less than G. Got it? So G cos theta is always less than G, because cos theta is always less than or equal to 1. So this is the second statement. Got it? Done? Noted? Okay. So we have discussed something called pitch of the wrench. So pitch of the wrench is nothing but, so G is equal to PR, where P is the pitch of the range. So P is the pitch of the range where G parallel to R, which is a range. And then actually we just proved that G cos theta will always come parallel to R, right? That means G cos theta is always parallel to R. So this R axis is the central axis. Now this value G cos theta, if I call this as K, which is the moment along the direction of the resultant force R, then this K and R always forms a range. If these two always forms a range, then based on this relation, K can be expressed as PR, or P is equal to K by R. P is equal to K by R. So where P is the pitch of the range. So this pitch of the range, if K equal to 0, then P equal to 0, right? So if P equal to 0, then K equal to 0, or vice versa, you can say. So if P equal to 0, then actually G cos theta is going to be 0, which essentially means that we are left with only the resultant force R without any moment. That means the system of all the forces results into a no circular motion, only a linear motion it results in case if P equal to 0. Got it? So the system of forces results into a single force, which essentially means that no moment. It results into a single force, which essentially means that it will have a direct effect of linear motion on the body. Now, if P equal to infinite, it implies that R equal to 0. If R equal to 0, then P will be infinite. In such cases, so the system of forces results into a single movement no effective force. Got it? So that is the importance of this P. So P will decide whether it should have only the linear motion or only the rotatory motion, or it can have both. If P value is in between 0 and infinite, then there will be an associated linear movement and there will be an associated rotational movement as well. So that will be decided by this P. Got it? Understood? So you can note down this. Done? Noted? Okay. So you can note down one more theorem. Whatever the origin whatever the origin and the axis are chosen, origin and the axis are chosen, the quantities x square plus y square plus z square and Lx plus My plus Nz are invariants for any given system of forces, are invariants for any given system of forces. Any given system of forces acting on a rigid body. So I'll give you 5 minutes time. Can you try to prove this? This is purely a mathematical analysis. See this, the problem statement, what it says is, whatever the coordinate axis we select and whatever may be the origin point you select, it is independent. The quantity is x square plus y square plus z square and Lx plus My plus Nz. So both are actually invariants irrespective of the origin what you select and irrespective of the type of coordinate axis you select. Now here actually by common sense we can make out. Suppose if there are certain system of forces, let us say there are 3 different forces that are acting on a body. Now actually it doesn't matter from where you look at, it always results into the same force, right? That means suppose if there is a body like this, so this is one force and this is one force and this is one force. Now actually a person standing here and then actually he is trying to look at these forces. Now this will have a definite resultant, and this resultant, let us say this direction of the resultant is this one. Now if the same person actually, if he looks from here, right, so the orientation may be different for him, but does this magnitude of the force will be a different value whether he looks from here versus here? Got it or not? Obviously no. That's what is this statement. Got it? That's what is the first statement. Irrespective of the origin and the coordinate axis directions you select, this magnitude it won't change, but the way you interpret is different. You are looking from here and you are looking from here, but this will not have any effect whatever the way you select it, right? So that is the first statement. And there is one more quantity, Lx plus My plus Nz, which is the product of or the dot product of the moment and the resultant force. That means here actually this value is xi plus yj plus zk, and this magnitude won't change. So x square plus y square plus z square will always be a constant whether you look at from here versus here. And g value, so if you start looking at from here, then actually definitely there will be an associated moment, and the moment value will be different the way you look at. Got it or not? So suppose if I say that I am standing like this, this body is to the right of me. Suppose if I am standing here, this body I say that this is to the left of me. That means the way we interpret the rotation is different. So, right? So that's why the movement will be different in both the cases, here versus here. And that moment value G is equal to, so Li plus Mj plus Nk. Now the dot product of these two, if you take it, so R dot G is equal to Lx plus My plus Nz. So this magnitude is actually irrespective of the way you select it. This is also a constant value. Now this is what we need to prove. This is anyway known for us. First one. Got it? So take this as one origin and then call this as R and G, and then take this as one more origin and call this as R dash and G dash, where R dash equal to R. and then but G is not equal to G dash. And then based on this assumption, you try to calculate the dot product of these two in first case and the second case. So this product and this dot product, you try to find out the relation between these two. And I have given one more relation in the previous classes. So I have proved a relation between G dash and G. G dash is equal to G minus C cross R. So this relation actually I already proved. So the way you look at, if it is different, the moment is going to be changed. And we have quantified that moment as equivalent to G minus of C cross R, where G is the moment when the origin is at O, and G minus C cross R, which is nothing but G dash, is the moment when the origin at O dash, and the vector C is nothing but a vector joining from O to O dash. So this is the vector from O to O dash, and this is the resultant force vector. And this is the new moment, and this is the old moment. Got it? So with this relation, if you try to find out the relation, so R is equal to Xi plus Yj plus Zk, and G is equal to Li plus Mj plus Nk. Now the dot product of these two is nothing but R dot G is equal to Lx plus My plus Nz. And then actually we'll try to prove if the other one is also equal. So you note down this, I am going to erase it, and then actually I will try to prove this relation with this dot product. Done? So let O dash be the new base point and I dash comma J dash comma K dash are the new unit vectors in the direction of the corresponding coordinate axis. Corresponding coordinate axis x dash comma y dash comma z dash. Then the new resultant force R dash equal to x dash into I dash plus y dash into j dash plus z dash into k dash. So unit vectors also different because actually it is independent of the axis whatever we select. So that also is there the problem statement. Hence, we have taken a random coordinate axis whose unit vectors are I dash, j dash and k dash. And similarly, g dash can be interpreted as this is so L dash into I dash plus M dash into J dash plus N dash into K dash. And the old moments actually you can express as old resultant force R is equal to Xi plus Yj plus Zk. And similarly, G is equal to Li plus Mj plus Nk. Now this dot product actually we proved that Lx plus My plus Nz, right? So here also if you try to prove it, R dash plus G dash, sorry, R dash dot G dash equal to, so R dash equal to, so R dash equal to R, we know that, right? So then actually, so this can be treated as Xi plus Yj plus Zk dot product with and G dash, so that is G minus C cross R. So this is nothing but R dot G minus C cross R. So if you do this dot product, this is equal into R dot G minus C cross R dot R. So sorry, R dot C cross R. Now if you notice, this is the scalar triple product. Got it or not? This is the scalar triple product. What is the value of the scalar triple product value? What is the value of the scalar triple product value? Okay. So let me explain. So this value actually for now you note down this as 0. I'm going to erase and then why it is 0 I'm going to explain. Anyway, yeah, some people give correct answer. So this is equivalent to R dot G, which is nothing but Lx plus My plus Nz again. Got it? So irrespective of the coordinate axis you select, irrespective of the origin you select, the product of Lx plus My plus Nz is always a constant value, and the magnitude of the force is nothing but x square plus y square plus z square under root is always a constant value. So that is for any system of forces, that is how it is. Now actually these relations we can make use to find out the pitch. Got it? You can note down this. Done? Okay. So let me give you a clarity on the scalar triple product. So let us consider three different vectors. So this is a parallelepiped. I call this vector as P, and this is Q, and this is R. Now, the dot product of any two different vectors, if I take it, that is, see this. So scalar triple product PQR, this is how actually we represent scalar triple product. Here the meaning of this is P cross R dot Q, or so any two you can interchange anyway, like P cross Q dot R or Q cross R dot P. So all these values are equivalent to each other. Got it? Now actually, if you take the cross product of these two, let us say R cross Q, if I take it, I am going to get a magnitude of the vector which is equal to R cross Q is equal to mod R into mod Q into angle between these two is theta. Then actually, so this is sin theta and a unit vector which is perpendicular to both of these, right? So this is a plane and there is a perpendicular to this one. And then if you do a dot product of this R cross Q, a dot product with P, then this value is going to be, so this is not R, I call this as T. So this is T dot P is equal to mod T into mod P into angle between the perpendicular direction. So let us say this is the plane and let us say this is the perpendicular or T vector. Then there will be an angle between these two is phi, let us say. Now this value, so T mod T is nothing but R into Q into P into sin theta into cos phi. So this is going to be a scalar value. Right? So if you notice here, what is happening is the magnitudes of all the vectors is getting multiplied, and the angle between two different vectors you have taken sin theta and the other vector. So the resultant vector with the other vector is making an angle of phi, then cos phi is the factor. Now what it essentially means for us is, see this, these two forms a plane, and a plane, a vector which is perpendicular to this plane is this one, and it is making an angle of theta. Now you have taken a component along this particular direction, right? So this vector taken a component along this direction, and then actually you are multiplying with the magnitudes, which essentially means that this area getting multiplied with this height, which will be the volume of this parallelepiped. So a scalar triple product will represent always a volume which is formed by those three vectors, right? So that is the fundamental understanding. So scalar triple product will be represented in a standard form like this, which essentially means that you can take cross product between any two vectors, and then that has to be considered with a dot product with the third vector. So if you take the bottom two vectors and then find out the area and multiply the height, you are going to get the volume of the entire parallelepiped again by considering bottom surface. So even if you consider this surface and this height, or bottom surface and the vertical height, or this surface and depth into the board, so always gives the same volume value. That's exactly the reason why we call this scalar triple product will give equal result in all the cases. And if you notice, the result is again a scalar value, which is nothing but the volume of this parallelepiped, right? Now actually if I give the fundamental question, if any of these two vectors are parallel to each other, then what would be the volume? If I take this vector onto this surface itself, then what will be the volume? What will be the value? If any two vectors are parallel out of these three, obviously it will make zero volume, right? So if it is making zero volume, obviously scalar triple product will be zero, right? So that's exactly the reason. In case of scalar triple product, if any two vectors are equal, then the result is always zero. That's exactly the value what we have used in the previous example. Got it? Any questions on this? Any questions? Yeah. So these are the concepts that are involved as part of this equilibrium of forces in 3D. So only thing what we left over is some of the problems what we can solve, and after that we can close it, right? I'm going to take 1 or 2 classes on only the problems. So once we are done with that, so we can shift to the next topic. Got it? So till then, good night. Yeah, thank you. So concepts wise, I hope no questions are there. Yeah, great.